Hi there, I'm Xiaojing, and with Weilong, Yongzheng, Yangtong, and Xiuying, we are Team Deep Phynance, and in this video, we'll present on economic forecasting of wind energy with neural network. We know modern society depends on steady, predictable energy sources, but wind energy mainly depends on environment, so we need to predict and hedge against shortfalls in energy production. In the simplified world, there are three players: grid operator, wind energy producer, and energy trader. Energy traders use the historical energy production data and wind data from wind farms to forecast the energy production to the grid. So the grid buy energy from farms based on this. Here, as an energy trader, our goal is to get a T plus 18-hour energy forecast to maximize profits.
To forecast the energy production of yield France region, we have two main datasets for analysis, including the historical data of energy production and wind forecasts of 8 relevant wind farms. After analyzing the historical data, we found that the correlation between energy and wind speed of Farm 6 is relatively high, while it is relatively low for wind farm 1. It is also found that the correlations between wind speed of different farms are different. Based on this analysis, the 8 wind farms can be divided into 4 important clusters, where Farm 1 is left out.
And there are two different models, which are both their best guess from observations. Here we use the average wind speed and the maximum wind directions of these two models for each cluster. As we can see, the energy and speed do not follow the normal distribution, so we use the minimum maximum scaling method to normalize our data. Directions will be discussed later. From the autocorrelation, the proper windowing of energy, speed, and the directions can be chosen as these figures show. The 8 farms open at different time. The date we use is from January 1st, 2018, and there is an energy peak and only farm 7 and 8 has not opened at this time. We use 19% of the date as the training set, which can include the 2 peaks, and the rest 10% and rest set.
The figure on the left illustrates how the wind turbines convert wind energy to electricity. In fact, only the vertical component contributes to energy production, and the power output is found to be proportional to the cube of the vertical velocity, so it could be an important feature. We use AutoCAD to build our wind energy forecasting model. The selected features include the cube of the vertical wind speed, the speed difference, and the mean, diff, and SD values of the historical energy production. Before fit to the neural network, the input features are first scaled, clamped, and the dimensional reduction is followed using autoencoder. Our optimized neural network has 4 layers. The first layer has 128 squared perceptrons.
For our final result, first, we derive the mean square error of persistence as benchmark to beat in our forecasting model, which is 0.025366. We run our best model 50 times, using the configuration as mentioned above. The lowest test loss is 0.006797, which is far less than the benchmark. As shown in the statistic calculation, the small value of standard deviation demonstrates our model is stable, and in the loss graph, the difference between training and test loss is only 0.001, which shows there is no overfitting in our model. The plotted momentum and false losses also support this point. The prediction graph shows our model generalized very well from training data to test data. The nearly linear relation in both scatter plot is also preferred in forecasting. The zero lag in lag correlation graph further reveal our model is well optimized and can predict timely. And having set our model, remember, our goal is to maximize profit. And currently, our net profit is 1.5 times 10 to 8 euro cents. To gain more profit, we measure the difference between prediction and actual value, which to be normally distributed in average zero. Based on statistical calculation, we manually shift our prediction to make the average difference equals to 0. In summary, our neural network is inspired by the model of physical theory, which has both advantage of AI and physics. We're using domain knowledge to do feature engineering, clustering, and windowing. Finally, our model is capable to gain huge amount of profit for wind energy producer. And of course, our model can be further improved. As can be seen, the low wind speed cannot efficiently output power, so we can remove them to help neural network to learn better. Thanks for watching.